load up the rendering basic starter.hip file, and we'll use this as the basis for exploring some of the rendering options available in Houdini. Drag the frame slider forward until you can see the flying toilet just in front of the tree in the background. Around frame 64 looks good. You always have a rendering option on the blue button in the lower left of the viewport. If you right-click on this, View Mantra is always available. And if you select this, mPlay, the image viewer that comes with Houdini, will pop up and Mantra will render the image into the mPlay window. The View Mantra command on the render button can be relaunched by left-clicking on this blue button anytime you like. So once you've used the right mouse button to select a renderer, you can use left mouse button to repeatedly re-render. However, as we'll see, there are faster and more efficient ways of checking your render than doing this. I'll close the mPlay window for now, and let's look at how we can define new render commands that have different quality settings. I'll split my viewport top to bottom to create a new pane at the bottom here. I'll unlink this and then change to Outputs. The Outputs pane is where you create anything that will be rendering from Houdini out to disk. There are quite a few different options. If you type Tab and go to Generators, you can render with Mantra, you can render with a couple of different OpenGL render previews, Ren, which is the outline renderer that comes with Houdini, Geometry to render actual geometry models onto disk, and the 3D texture generator, which is covered in a separate exercise. We'll use the Mantra render output driver and type P to open up the parameters for that. It's generally a good idea to rename the output driver, since when you right-click on the render button, it will show up as part of a list. So let's rename this one to Mantra _ low res. And we'll configure this one for speed, but not for quality. There are two places that you can adjust the quality of the image, globally in the render driver or individually for each object. Let's start with the render driver. The guts of the render driver is the render command. Click the plus button next to the render command, and you'll bring up quite a lot of options that can be used to control Mantra. The main control for quality is under micropolygon and is the shading quality. With a shading quality of 1, you're getting normal render quality. If you change this down to 0.5, you're now rendering essentially half the amount of geometry because the micropolygons will be much larger. To have a much higher shading quality, you would set this to be 2 or higher. Normally you can render at a shading quality of 1 for final renders. 0.5 is good for testing when you want more speed. Click Accept. Also, reduce the super sample down to 1 by 1. Super sample is the amount of anti-aliasing. 3 by 3 is considered normal. 1 by 1 is no anti-aliasing, and anything above 3 by 3 is higher quality anti-aliasing. This also needs to be raised when doing motion blur, as we'll see later in this tutorial. Now come up to the viewport, right-click and select the Mantra low-res render output driver. And Mantra will render into the viewport, and you'll see that the quality of the render is not very good. There's a lot of jaggies, and the texture is not very well defined. This is because the shading quality has been turned down. You can also turn down the jitter to 0, and this will reduce some of the jaggies when doing test renders. If you want to compare the images as you work, you can leave mPlay open. You don't have to close it every time. So if I turn up the super sample to 3 by 3 again and have the jitter down at 0, let's move this out of the way, I'll just left-click on the render icon and Mantra will render again into the same mPlay window. Once you start to accumulate frames, down at the bottom you'll be able to jump back and forth between the different frames that you've rendered. There's also a full suite of image comparison tools in mPlay. However, that's not covered in this tutorial. You'll notice that by turning up the super sample and reducing the jitter, that we now have nice smooth anti-aliased images. However, the quality of the textures is still not very high. This is because of the shading rate being set to 0.5. You can click the plus button and come back and turn the shading quality back to 1 and then click Accept. And you notice that that actually changes the number here in the render command window. So you don't need to click the plus button to change these options if you don't want. You can just come in here and enter a number directly. So minus S1 will set it back to be normal quality. Then we can take a look at another render just by left-clicking on the icon again. You'll notice now if you change to the previous frame that all the textures are much sharper and much better defined. Reducing the shading rate will increase the speed of the render, but it will reduce the quality of the render. However, because this is Mantra low res, let's set this back down to minus S.5, reduce the super sample to 1 by 1, and then make one final adjustment to increase the speed a little bit more. You can see that this scene has ray traced shadows turned on. Whenever you're doing ray tracing, there's another control in the render command, if we click the plus button, under the standard page called ray tracing level of detail. If we turn this on and set it to 0.1, down from the default of 1, click accept and then render one more time, you'll see that the render goes faster. Also, the quality is reduced, but that's because we set the shading rate down. Level of detail basically reduces the level of detail of the geometry only when a ray traced shadow, reflection, or refraction is required by the renderer. Normally you can set this lower than 1 and not see any problems. Occasionally you may need to turn this back up closer to 1 if your ray traced reflections are very close to the camera or you're seeing extreme amounts of detail in the reflections or the refractions. As always, you'll need to play with these parameters with your final render to make sure everything's of a quality that's acceptable for your final result. Let's set up another Mantra output driver that will be the final result. In other words, the best quality. So I'll type tab, go to generators, select Mantra again, and rename this one to be Mantra underscore high res. The default super sample of 3 and 3 is fine for a final result, so we'll leave that alone. We want to set the resolution of the final result. With this turned off, the default resolution is actually taken from the camera that you're looking through. Let me close this MPlay window for a second. Take a look at the camera parameter of the render output driver, and you can render through the camera or through lights actually, although for this exercise we'll only be rendering through camera. In camera 1 in the objects, under the view, the resolution of the camera is selected here. On the right, there's a number of default resolutions available that you can choose from. So for example, NTSC full will give me 640 by 486. In the render output driver, override default res is only needed if you want to render at a different resolution from what the camera has selected in it. So Mantra low res, if we go back to that one for a moment, we need to turn on override default res, go to the arrow and select NTSC 50% so that we get half NTSC resolution. Mantra high res, we don't need to turn this on because our high res or final result will be NTSC full res, which is what the camera is set to. Let's take a look at motion blur on different objects. The flying toilet, which is moving past the camera right now, is a prime candidate. So we'll go to the flying toilet object, go to the render tab, and set the motion blur to transform blur only. The other two options, deformation blur and velocity attribute blur, are more sophisticated examples that won't be covered. However, deformation blur is needed whenever you animate inside the object. In other words, anytime a SOP is animated, you would need deformation blur. Velocity attribute blur is perfect for rendering particles because the particle count can change and the blur will always be correct. Velocity attribute blur can also be used for a large variety of special effects. Transformation blur is fine whenever the object is animated right at the object level only. So this toilet is actually on a path, so transformation blur is perfectly acceptable. To test render this, we'll need to use the Mantra high res or modify the Mantra low res. The reason for that, if we try to render with Mantra low res, for example, you won't see any motion blur. And that's because the super sample is set to 1 by 1. Motion blur has to have a super sample of at least 2 by 2 before you see it. So we can either render with Mantra high res, or in this case, let's modify Mantra low res to have a super sample of 2 by 2. Let's move this out of the way again. and then re-render it one more time. It's still quite fast, but now we can actually see the motion blur. However, the quality of the motion blur isn't very good because the super sample hasn't been set very high. You will find that you will need to set the super sample higher than 2 by 2, sometimes even 4 by 4 or 5 by 5, depending on how fast your object is moving. Also, in the render page of an object, there are a number of controls, including the shading quality and level of detail, ray clip, and ray bounce, all of which affect the render. Ray bounce and ray clip are used whenever you're doing ray tracing, especially with reflections and refractions. You can turn these down to increase the speed, but potentially reduce the quality of the ray tracing. Shading quality is just like the shading quality in the mantra command. If you turn it down, it will speed up the render of this object at a cost of the quality of the texturing. However, if your object, like the toilet, is moving very fast, you may want to turn this down while it's moving past the camera, and that will speed up the render of the object moving past the camera. You can always keyframe this by right-clicking on it, setting keyframes, and animating this up and down as the object moves through the scene. Level of detail is also the same as the global one on the render command, but applies only to the single object. There are many other options available in Mantra that we cannot cover in this exercise. Please see the reference documentation for much more information. Let's set up a render now to render to disk this entire animation. I'll use the Mantra High Res in this case to render out to disk. So I'll drag back up to the top here, turn on frame range so that it will render more than one frame, in this case 1 to 300. The output picture by default is IP, which just means image player. So if I were to click render right now, it would render all 300 frames into a RAM buffer in MPlay, and you could see it immediately. If you wanted to, you could then save it from MPlay to disk. Normally, though, you would render directly to disk and then look at a flipbook. For the output picture, I'll click plus, navigate to a directory where I want to render to. I'll just render into the temp directory. And I need to give it a name, so I'll call this toilet dot, and this part is extremely important. You must have $F in the name of the file. $F gets replaced by the current frame number when rendering. If you don't have this in here, you will get 300 images with the same name. In other words, you'll just get a single image that keeps writing over top of the previous image, and you could waste a whole night's rendering. So always make sure you have $F in the name. Then give it a suffix. The Houdini format is .pic. However, you could also use .tga, .tiff, .sgi, .bmp, whatever you prefer based on your platform. Once you entered the name, again with $F as part of the name, and frame range is turned on, make sure you're rendering through the camera that you want, which is Cam 1. Click render and your frames will be rendered to disk. If you want to render on more than one CPU, if you have a dual CPU machine, or if you have multiple computers in your facility that are networked, you can split a Mantra rendering across multiple CPUs on the same machine or on remote machines. You do this by going to the render command, clicking plus, and turning on remote hosts. With this turned on, you then enter the names of the machines with no spaces separated by commas that you want to render on. So for example, to render on 2 CPUs on the same machine, on the local machine, I would type in localhost, localhost, click accept, and now when I render with Mantra High Res, both CPUs will be used on the local machine. Just minimize this for a second. I can click the plus button and enter other names as well. So for example, I could use snake, snake, which are 2 other machines that I have here. Now I'll have Mantra render across 4 CPUs. When you're using the remote hosts option, it's a good idea to set the bucket size higher than 16. For example, 32 or even 64 are good values. To control the size of the motion blur, go to the camera in the View tab and adjust the shutter speed. The default of 1 is not very realistic. 0.5 is actually a realistic film camera speed, with the shutter being open only 50% of the time. So it's a good idea to set this down to 0.5 for a more realistic motion blur. Also, the lower this is, the faster the render will be because the motion blur won't be as extreme. That concludes our basic overview of how to render your images in Mantra. Don't forget $F as part of the file name when rendering to disk.